Welcome back to another video on configuring DMVPN on Cisco iOS devices. If you've watched my previous videos, you would see that we have already configured DMVPN on Cisco iOS devices for hub and spoke deployments. Now what we're going to do in this particular video is we're going to take a look at how to configure basically a full mesh deployment, so whereby the spokes can speak to each other. So once the connection or the tunnels are formed with the hub, then we can also now take a look at how we configure spokes so that they don't have to traverse through the hub just to reach another spoke. They can actually just speak to one another, or traverse or form a VPN with one another. So this presentation is the same. I'm just bringing this back up here, particularly this slide here, because I want to just remind you, for those that have watched the previous video, that the only real difference in what we did in the previous video when we configured a partial mesh deployment to what we're going to do now with a full mesh deployment is actually pretty much one configuration on the tunnel interface that we configure. And what we're going to do is we're actually going to change from using the tunnel destination, so where we specify the tunnel destination as being the hub, to actually using or specifying the tunnel mode as GRE multipoint, which is going to allow us to form those spoke to spoke tunnels, if you like. So we'll take a look at that in the lab in a moment. For those that have not watched my previous video, I do urge you to head over to my YouTube channel and look for a DMVPN related configuration video. So with regards to the topology, we're going to be using the same topology here. In fact, all I've done from the previous video was actually change out the VPCs so that I'm now using or making use of the some Linux servers as well, just because I had a few issues with the VPCs previously. Aside from that, everything else is the same. Everything else will stay the same. So this is the topology that we're going to be working from. So without further ado, let's get into the lab. So I have a couple of Ubuntu machines now in place of the VPCs, as you can see. So all these are configured already. So for example, with this machine, if I ping, this is a branch 1 machine. So if I ping 172.16.20.1, we get a response from router 10, which is on the bottom left hand side there. And that'll be the same case for the other devices as well. Now in terms of the routers, if we just do a show run there, we can see that all we really have configured are the interfaces as well as BGP to form that adjacency between the ISP router in the middle as well as the other sites as well. So you can see we've got those adjacencies there up and running. So what we're going to do is we're going to start again by configuring the hub, which is going to be this particular device here, which is router 10. And then what we're going to do is we'll configure both router 11 on the top right hand side at the partner site, as well as configuring the branch 2 site router. Both are spokes, but we'll configure them in a way whereby they can form tunnels between one another rather than just sending traffic through the hub to get to one another when wanting to communicate. So we'll configure the hub first, as I say. So what we'll do is we'll start by configuring, again, it's probably just worth actually just quickly flipping back here to the hub configuration. So for those that didn't watch my previous video, this might be more relevant to you. So we can actually optionally configure the IKE v1 or IKE policies because we have defaults already configured if we don't configure them. Same with the phase 2, so with the IPsec transform sets, we can actually configure those or leave those alone. We don't have to configure those if we don't want to, because again, we can make use of default as well. So it's totally up to us. So what we'll do is in this particular video, we won't configure the IPE policies and we won't configure the transform set, and I'll show you how we can actually make use of the default one as well. So if we just start off now by, if I just flip back to this, if I start off by now creating our key, do crypto ISKMP key, and then we'll specify our key here. So we'll just use Cisco for the purpose of this demo. And our address we will specify, so we'll do this twice, so we'll specify the address for the partner as well as branch 2, and this IP address is going to be the external IP addresses here. So we'll configure 209.209.209.10, and that's going to be for the partner site. And then if I do crypto ISKMP key, and we'll say Cisco again, and this time it's going to be for the outside interface of the branch 2 site, so 209.209.209.14. So as I said, the phase 1 or the IPE policies are optional, so we won't configure them in this particular video, and we also will leave the transform sets, and we'll make use of the default transform set that exists on the device. So all we have to do now actually is just go straight to the tunnel. So if I just create a tunnel called tunnel 0, you can see there now the tunnel's been created, but the state is down until we configure it. So what we need to do now is we'll configure the IP address of the tunnel. So I've got a range of 192.168.10.1, as you can see on the screen there on the topology, to 10.4. So we'll give this the IP address of 192.168.10.1. And then once we've done that, we can specify now the MTU of 1400. And then we'll do our next stop resolution protocol authentication, so IP NHRP authentication, and we'll give this a key, if you like, of Cisco 123. That means for our NHRP authentication, we also need to configure the same on the spoke devices as well, so that we can authenticate with the other devices as well. So we'll now do NHRP, IP NHRP network ID. So we'll give it a network ID of 1. And then we'll do IP NHRP map, multicast, and then dynamic. So that's our MGRE for this tunnel. So this is going to make it a dynamic tunnel there. We'll do our TCP MSS, we'll set to 1360 segment size. Okay, and then we'll do our tunnel source. So our tunnel source is going to be, so we're on the branch when we're creating our hub configuration. So our tunnel source is going to be the outside interface of the router. So it's tunnel source ETH00 in this case. And then we'll say tunnel mode GRE multipoint. So this is actually this is actually the MGRE for this particular hub. So we'll see how we can configure that on the spoke devices as well. But as you can see now, the state has changed to up, which is excellent, which is what we want to see. And we'll configure a tunnel key of 1, and that will need to match on the spokes as well. Now, when it comes to the applying the IPsec protection, tunnel protection IPsec profile. Now, because we didn't create an IPsec profile, what we can do here is actually say default, and it's going to make use of the default configuration on the device. And that's pretty much it for the hub configuration. We do have obviously the dynamic routing to think about, but we'll come back to that once we've configured the tunnels for the hub devices as well. So let's head over to our hub devices here. So this is Route 11. So this is the partner site now. And now when it comes to the configuration here, everything's going to be pretty much the same, if not the same. Again, we optionally can configure phase 1 as well as the phase 2 IPsec transform set. So again, we'll leave that. And what we'll do now is we'll say crypto, ISA KMP, key, Cisco, and address. Now with the address, we're actually, if we are configuring a hub and spoke or partial mesh deployment, as we did in the previous video, what we would do is we would actually just specify the hub or specify the key for the hub. But because we're actually configuring a full mesh deployment, we need to specify the keys for the other spokes as well. So what we'll do is we will configure this address now at 209.209.209.6, and that's going to be towards our hub. And then what we'll do as well, we'll configure the key for the branch 2 site, so 209.209.209.14. all right, cool. So once we've done that, again, we can jump straight into the tunnel and we'll start configuring that. So we'll say IP address for this one is going to be 10.2 because we said 10.1 for the hub. We'll do our MTU at 1400. We'll do our NHRP authentication as Cisco 123, I think it was. We need to keep the map multicast, so we need to specify the up still, so 209.209.209.6, and then we'll do NHRP, and then we'll map the logical tunnel address of the hub to the physical IP address of the hub device, which is 209.209.6. There we go. And then we'll do IP NHRP network ID, and we said 1. NHRP has quite a few configurations, so it's easy to get confused sometimes. So once we've done that, we'll do IP NHRP. Let's do next up server 192.168.10.1. And then once we have done that, we can do the maximum segment size IP TCP MSS. And then we'll do 1360. And then we'll do our tunnel source as Ethernet 00, which is the physical outbound or outside interface of this particular router. And now what we do to specify that MGRE on the spokes or create that full mesh deployment is we actually need to do tunnel mode GRE multipoint, whereas normally with a configuration where we're routing everything directly through the hub, we would just specify the physical IP address of the outside interface of the hub. So we'll say multipoint GRE or MGRE there. You can see that the tunnels come up, and now what we need to do is we need to specify that tunnel key again of 1. And then lastly, IP sec tunnel mode, tunnel protection IPsec, and then we're going to say we're going to use the default IPsec profile default, and that should be the configuration done now for this spoke device. So if I just do show crypto ISA KMP, SA. So we can see that we've got a security association which has a status of active there. Let's check our phase 2 or IPsec SA. All right, cool. So you can see that that's up as well, and we've got one in cap, one decap as well. So that's looking good on that side. So we'll leave route 11 there as it is, and lastly what we'll do is we'll configure now route 8, which is branch 2. We'll do that configuration quickly this time. So we'll do crypto ISKMP key Cisco address 209.209.209.6, and then we'll also say 14, no, not 14, because 14 is the device we're on now. We'll also say 10, which is the partner device or the partner router, partner site. And then we'll jump straight into the tunnel configuration, and we'll say IP address 192.168.10.3. All right, so once we've done the logical IP address of the tunnel interface, we can say, or tunnel IP address, however you look at it, we can now do the MTU 1400, and we'll do our NHRP authentication of Cisco 123, and then we'll do IP NHRP multicast, and then we're going to specify that hub physical IP address again, which is 209.209.209.6, and now we'll do the mapping between the tunnel interface IP address of the hub, so 192.168.10.1 to the physical IP address NHRP, and then we'll do our network ID of 1 again, and then we can do our next op server. NHRP next op server is going to be 192.168.10.1, so that's a tunnel IP address of the hub. Let's do our maximum segment size, adjust MSS to 1360. Our tunnel source is Ethernet 00. Tunnel source. And now we can do our, specify our tunnel mode. That's GRE multipoint. Do a tunnel key, and then tunnel protection IPsec profile, and we're going to use the default profile again. There we go. Do show crypto. That's PSA. So you can see our phase 1 there is active, which is good. Let's have a look at our IPsec. Okay, that's good as well. So now if we take a look at the hub, see what's going on here. On route 10, show crypto, we should actually have 2 SAs. There you go. So you can see we've got 2 security associations there. And similarly with IPsec, we can see that we've got our IPsec security association here for, this is between dot 14. So this is between the hub and router 8 or branch 2. And then if we come down here, we've got the hub between the partner site as well. So you can actually see we've got 2 SAs there as well, which is what we'd expect to see because we've got 2 essentially spokes. And what you probably noticed here is that we don't have any between the 2 spokes. Actually, we don't have any security associations. As you can see there, everything's going back to the hub. So we'll take a look at the output again once we've configured our routing, and we'll see what that looks like once we start to send some traffic between the spokes, where initially, or where we configure partial mesh, we would traditionally see that traffic from spoke to spoke traverse the hub. We'll see what happens once we, now that we've got full mesh in place. So firstly, what we need to do is if we just go back to router 10 now, and let's do, I think in the previous video we configured EIGRP, and you saw how we had to make a few modifications on on OSPF for OSPF to function properly with DMVPN. What we'll do in this particular video is we'll take a look at how to configure EIGRP with DMVPN as well. So if I just do root to EIGRP1, let's do network 172.16.20.0. And then we also want to do our 192.168.10.0 network, which is our tunnel subnet. Let's just leave it like that for now, and let's go across to our Spoke devices and do the same. EIGRP1, and let's do network 10.0.10.0. And then we'll also do 192.168.10.0, and we should get an adjacency formed. So there you can see that adjacency is being formed by tunnel 0, which is what we like to see. So if I just do show IP route there, we can see now that we have a route via our tunnel for that branch 1 subnet, which is great, which is what we expect to see there. Now if I go to, and in fact just before I do that, if I quickly do that, you can still see we only have our security association with the hub there. Now let's configure the other spoke. So router EIGRP1 network. So this is the branch 2 router. So we'll say 172.16.30.0, and also the tunnel subnet 192.168.10.0. All right, so now if we do show IP route here, we can see now that we've got a route to branch 1's subnet via the tunnel, which is great, what we'd expect to see there. You can see as well that we don't have any route to the partner sites subnet, so you can't see any 10.0.10 in there. So let's see if and what that looks like once we start to send traffic. So what we'll do, actually sticking with branch 2, now that we've got EIGRP in place there, you can see that we've got 2 tunnels here, and if we look at the hub, you can see that we know about the branch 2 subnet, and we also know about the partner subnet there as well. So let's go back to our branch 2, and this is our branch 2. This is our branch 2 device, or VPC, what would be VPC4 there on the bottom right hand side of the topology. And what we want to do is we want to start by pinging the partner site VPC3 at 10.0.10.10. You can see there that that destination is unreachable there. So that's not what we want. That's not what we expect. That's not what we like. Now let's see if we can ping 172.16.20.20, which is what we expect to be able to ping at the hub site. And as you can see there, that is correct. That's what we would like to see. And quickly we'll just go there, so you can still see there that that's not we still can't reach the partner site from branch 2. So we need to investigate why. We need to have a look at why we can't do that with our standard EIGRP configuration, if you like. So before we do that, let's just have a look at the IPsec SA on the hub, crypto IPsec SA. What you can see here, so you can see that we've got encapsulated packets and decrypted or decapsulated packets as well, which is great. So that's telling us that the traffic that's traversing that tunnel is being protected as well, which is what we'd expect, which is great. So what we'll do now is let's just go back to router 8, and again, if we just have a look at the routes, you can still see that nothing's changed. So we need to look at EIGRP and understand why we don't have a route to the partner site, or why don't we know about the partner site, and why can we not ping that or reach resources on that site. So what we actually need to do in the configuration for the hub, for the DMVPN configuration, we actually need to add a few things for EIGRP. So if we just go back across to our hub device now, we're just going to our tunnel. We actually need to first turn off split horizon, because what this is going to do is the current state is not going to allow us to advertise the IGRP routes that are learned via MGRE. So basically via our tunnel. So we actually need to turn this off. So if we just do no IP split horizon, GRP1 for our process, and the next thing we need to do, you can see there that split horizons changed. Let's have a look just before we add the next command. Do show IP route on one of the spokes. So we can see this is route 11. So this is the partner site router, and already what you can see here is, and you can see the time actually. Since we added that command, now you can see that we've got that route now to the spoke site as well. So that's one thing. So let's just do show crypto. So you can see we've only still got one security association on that spoke as well. So what we'll do is we need to now enable or configure no IP next hop. But let's question mark it, and let's look at the description. So next hop self, this is going to configure EIGRP IPv4 next hop self, and basically what this is going to do is it enables us to enable spoke to spoke tunnels when using GRE, so EIGRP rather. So we need to make sure that this is not on. So we'll do no IP next hop self, and then we'll specify the process again, EIGRP1. There we go. So you can see there that a few changes have occurred there. We'll just check that we still have the routes. Do show IP route. So this is on the hub, so we can see that we've still got the 10.0.10.0 network, which is the partner site, and we also have our branch 2 site network as well. So it all looks good there. Let's have a look at do show crypto. We can still see that we've got our security associations. Let's go across now to one of our spokes. So this is route 11. And let's have a look at our SA. So we've still got one SA. Do show IP route. And again, we can still see there that we have the network for the hub subnet, and we also have the partner subnet as well. This time, let's go back to. So it'll be the same actually on the partner site. So this is Just make sure I'm on the right device here. So we've got router 8. Yeah, so this is right. So this is branch 2's router. So do show IP route. So you can see there that we have the subnet for the hub, and we also have the subnet for the partner site as well. So now on our VPC4 on the bottom right hand side there on branch 2, we should now be able to ping. So we'll try and ping the branch 1 site first, our hub again. So we know that that worked. It worked last time, which is good. Now let's see what happens when we try to ping the partner VPC3 on the top right hand side. So we can see there that now that is perfect. That's fine. But you can see there now something's changed. So this is going to show us that we should have a spoke-to-spoke tunnel now. So if I have a look at, let's do that. So now you can actually see that we've actually got, when we look at our security association there for phase 1, we've actually got a tunnel now, a spoke-to-spoke tunnel that's been formed on router 11. So this is on the partner site to directly to router 8, which is dot 14. So you can see there that we've got that connectivity, that direct spoke-to-spoke connectivity. Do show crypto IPsec SA. And again, you can see there on this spoke, we have the connectivity between, so we're on route 11, so we're on the partner site, so we can see our connectivity, direct spoke-to-spoke connectivity here. We can see that the packets are encapsulated, decapsulated, so we can see that it's encrypted as well. And that's pretty much, that's all there is to it really in terms of configuration. And when we start to look at applying dynamic routing protocols, so we saw in the last video how and what we needed to do to get OSPF to work optimally or functionally at least, and we also looked at what was required now when configuring spoke-to-spoke using GRE, so full mesh deployment essentially. Let's just have a look at, let's go back to our hub and let's just do show DMVPN. So we can see there it's basically got our peer as well, our peer addresses there mapping to the physical and tunnel IP addresses. We can see that they're up as well. And we can see that our attribute is D, so we know that that's dynamic. Now if we look, let's go to one of our spokes and we just do the same, do show DMVPN. And what you can see here is we've got a mapping, a static mapping to our hub, and then we've got that dynamic mapping for that spoke-to-spoke connectivity there as well. So you can see what that looks like. So you can actually see as well the uptime on the hub to spoke has been longer, obviously because we didn't configure the spoke-to-spoke stuff until later on. And there you can see the time that we've had that connectivity established there for the spoke-to-spoke connectivity. Let's do show IPNH IP traffic. There you can just sort of see, similar to the last video, you can see the resolution requests, replies, and registration requests as well. And that's on the hub, and similarly on router 8 you should be able to do show DMVPN. Let's do detail, and what we can see here is we can actually see the same information really just on the other devices. So we can see that we've got that static tunnel towards the hub. We can see there that we've got the dynamic tunnel towards the other spoke site, 10.2 there, and there we can see that on router 8 here, so we can actually see that we've got the map in here with our our device here as well. If you just scroll down there, we've got IPsec or tunnel information there, rather, so we can see that we've got the tunnel, we've got the active SAs, we can see basically what's permitted, what we've configured essentially, and slightly different view of sort of packets that are being decrypted, inbound and outbound encrypted as well. So you can see there that that number matches there, which is great. So thank you for tuning in. I hope you found that useful. Again, that's how we can configure a full mesh deployment of DMVPN. And we've applied EIGRP as a dynamic routing protocol there. I hope you found this video useful. Please do like and subscribe, and also leave your comments if you have any questions. Thank you for watching.